Hey guys, my name is Lindsay Markham, and the genetic disorder that I chose to study is phenylketonuria, also known as PKU. So I'm going to tell you a little bit about this disorder today. So just a little bit of history about PKU. It was discovered by Asbjørn Folling, a hard pronunciation, but in 1934. And he actually discovered phenylketonuria when he was studying two kids that had severe intellectual disabilities. They used classic organic chemistry to determine that they were excreting phenylpyruvic acid in their urine. And then in a further investigation, they found 8 more patients that had the same thing. So they originally described this as oligophrenia phenylpyruvica, and that was a new inborn error of metabolism. And they later renamed this phenylketonuria. And up till this point, no other inborn error of metabolism had been shown to affect the brain until this disorder. So the molecular cause of this disorder, it is an amino acid disorder. PAH gene mutation is actually the technical cause. So what happens is there's a PAH gene where the mutation is, which normally provides instructions for making phenylalanine hydroxylase, which is an enzyme. This enzyme normally converts phenylalanine into tyrosine, which then makes hormones, neurotransmitters, and melanin, but this can also be broken down into smaller units that can also be used for creation of energy. Classic PKU occurs when this phenylalanine hydroxylase activity is basically absent or significantly reduced, and there is a severe buildup of phenylalanine. So the chromosomal location for this of the PAH gene is the 12q23.2. So it's actually on the long Q arm of the chromosome 23 at the position of 23.2. So just some descriptions of the signs and symptoms. So for severe, the symptoms depend on the level of severity of the reduction of phenylalanine hydroxylase function. So if there's very little to no function of this enzyme left, if it's severely reduced or absent, then the buildup of phenylalanine will be way more significant and can cause things like seizures, delayed development, behavioral issues, and psychiatric disorders, and other symptoms resulting from brain damage. And this is what we call classic PKU. And then if the enzyme still remains somewhat intact and functional, the buildup of phenylalanine will be less severe, so this leads to less severe symptoms. So they'll have skin disorders like eczema, light-colored skin or hair because of that melanin decrease, and then they call it a musty odor. So description continued. So this is a really big deal in pregnancy and in newborns. So women with PKU are considered to be high-risk pregnancies. Their risk is way higher if they don't follow a low phenylalanine diet. And then if they don't do this, then their risk of miscarriage increases significantly. Effects on the baby itself, they can have low birth weight, they can have slowed growth, heart defects, microcephaly, which is a small head, and other behavioral issues. So it's really important that these pregnant women are sticking to their low phenylalanine diet in order to have healthy pregnancies and healthy babies. So prevalence, it's pretty diverse depending on the geographic location and the ethnic groups that you're actually studying. In the US, it occurs in about 1 in 10,000 to 15,000 newborns. So as far as symptom management for this, it's basically diet. There's not much that we can do other than create a diet that has low phenylalanine. So as you can see, high protein foods often have high phenylalanine, so fish, meats, cheeses, milk, all of that kind of stuff is high in the phenylalanine. So this is the kind of stuff that they want to avoid if they have this disorder. Low phenylalanine foods include like fruits and veggies, special breads, and then for infants that have the PKU, they have to have a special low protein formula. Just continued symptom management. So early intervention is the most important and best way that we can avoid worsening symptoms. So as you can kind of see in this little cycle here, the elevated blood phenylalanine levels kind of go down this tangent of all of these symptoms and signs of this disorder. So the idea is that you break this chain early in the cycle and treat it with a low phenylalanine diet to avoid the deficits in executive functioning, the difficulty adhering to therapy, further elevated blood phenylalanine levels, neurocognitive and neuropsychiatric symptoms, and then, just as you can kind of see going down this chain. So the idea is that you intervene early and go ahead and decrease and prevent some of your major symptoms. The mode of inheritance of PKU is an autosomal recessive pattern. So affected individuals, they have both copies of the gene from both of their parents are mutated. Carriers generally do not exhibit signs or symptoms, but they can obviously pass this along to their offspring. So right here, I've just provided a pedigree for you. This is actually the one that I created for the course. So as you can see, the pink are carriers, so they would not have any symptoms. But as you can see, 2 carriers can lead to a child that is afflicted with the PKU. And then they can continue to pass that along throughout the generations. So genetic testing options, you actually have a large variety. The major testing option that we have for PKU is actually on a newborn screen, which is now mandatory in all 50 states. So what happens with this newborn screen is, we do it all the time in the NICU, is we just have a paper, and then like you can see in this, you just collect 5 little spots of blood from a heel stick in a newborn, and then we send that off as a send-out lab, and then we usually get results in a few weeks. These newborn screens generally test for a list of disorders, including PKU. PKU is one of the first that they were kind of consistently testing for, but they expanded that. So depending on what state you're in, they will vary in what disorders they actually test for. So they do that right after birth, usually within the first 24 hours. And then generally they do at least one more about 7 to 10 days later, and that's to see how they are, what their results are like once they've started eating. A lot of times newborns in the NICU don't start eating until a day or 2 of life, just based on their own symptoms. And then what they usually get tested and caught, the PKU gets caught at the beginning with a newborn screen. That's the idea, is early intervention, early testing. But there are also several other biochemical and molecular genetic tests that can also detect PKU. So these include just protein and enzyme levels. Usually those are including like a plasma level, and they test those plasma samples. And then you can also have molecular genetic tests, including deletion and duplication analysis, microsatellite instability testing, mutation scanning of entire codon regions, sequence analysis of select exons and entire coding regions, and targeted variant analysis. So these are all just kind of a list of different molecular genetic tests that can be done later. And these all range in cost. Most newborn screens are generally covered by insurance, but it can be an ethical issue if it's not covered by insurance, considering it's mandatory, and if parents decide they don't want it, they can't really decide that. So that becomes an ethical issue at some point. But these are overall kind of a compilation of the genetic testing that's available. So here are my references if you would like to check out any of this information. It's pretty interesting, definitely very relevant, especially in our NICU. So yeah, thank you so much for watching, and I hope you enjoyed this cute picture of a baby, and have a wonderful day.